this question is all about partitioning. And if you remember, we have to kind of make a right triangle with this, and then we're going to partition each side. So if we make this right triangle here and here, and if we look, this side is 7 units long, and this left side is 14 units long. So we can partition this. 7 will go into 7 and 14. So that helps us. So 7 divided by 7 is 1. So this needs to be partitioned off in segments of 1 unit. I'll make that one better. And then 14 divided by 7 is 2. So these segments or partitions should be 2 units long. Now on the side that's given, the ST, because this is S and this is T, we want to make a point on there where these 2 lines meet. Okay, so let's get rid of all those and let's do this. So this one and this one meet at this point. And then this one meets right here. And so if we keep going, we do the same thing. So now if you look, here's 1, 2, 3, 4. Let's try that again. 4, 5, 6, 7 sections. Okay, it says it wants it 5 to 2. 5 plus 2 is 7. So this point right here makes 5 to 2. So this would be point Q. And if it wants to know what the coordinate is, it is 3, 4. This question is asking about arc length, and it's in radians. So arc length has to do with the circumference of the circle, which is 2 pi r. And it has to do with, you have to know what your central angle is to find your arc length. So if you know what your radius is, 3, so when you're finding your arc length, you're going to have theta over 360 times your circumference, or 2 pi r. In this case, r is 3. So you will be multiplying everything by 6 pi. So you're going to take your degrees, put it over 360. You can reduce that, multiply it by 6. It wants it in radians. We're going to keep pi in there until it says, hey, round to the nearest whatever, because remember, pi is giving us our exact answer. So for this one, AFB, which is right here, we have 120 over 360 times 6 pi. And if we, you could do this, you could just go 120 times 6 divided by 360, and you're going to get 2 pi. For the next one, BFC, so BFC is this one. It's 45 over 360 times 6 pi. So in your calculator, don't calculate pi yet. So 45 times 6 divided by 360. You may get a decimal there. So we'd have to go 45 times 6, and we can reduce and go to the video from yesterday's and it tells you fractions in your calculator. So that decimal you can convert back to a fraction, and it'll give you 3/4, and that pi you would put up there with your 3. So 3 pi over 4. Please go back and look at how to do the fractions in your calculator. The next one is CFD, which is this one, and that's 30. So you're going to go 30 over 360 times 6 pi. And when you go 30 times 6 divided by 360, you're going to get 0.5, or you can change it back to a fraction, and it'll give you 1/2. So 1 times pi is pi over 2. You probably won't ever see 1 pi over 2. You'll just see pi over 2. And then the last one they're asking for is AFE, which is this one. Well, there's no degrees there, but remember this whole thing is 180, so 124 and 180 leaves 60 degrees. So you're going to go 60 over 360 times 6 pi. So 60 times 6 divided by 360 would actually be 1, and so 1 pi. Here's those rigid transformations. Remember, it doesn't change the size and shape, it just changes the way it's positioned. So I've drawn out the triangle that has been given, and then it says reflected over the x-axis and then rotated 180 about the origin. So we're going to do this. We're going to reflect this about the x-axis. Remember, this is your x-axis. We're going to reflect it. So if it takes 2 to get here, it's going to take 2 to get to the new one. Same thing for this. And here is triangle. Then A prime, B prime, C prime. Actually, this is B, this is C. So this would be C prime. I just said that. Yeah, no. And B prime. And now we have to rotate it 180 degrees. Well, if I took it and I moved it over here, that is 90 degrees, and then one more will be 180. So it's almost like if you folded this piece of paper on this line, that would be 180. So my A would end up here, my C would end up here, and my, I'm actually one off. And my B would end up here. So this is A double prime. And this is, these are now my coordinates. So if you look at these double prime coordinates, these are them. Okay, here's another rigid transformation question. We are going to rotate this clockwise 270 degrees and then reflect it on the y-axis. Okay, and it says about this point. So that is right here. A is our point of rotation, okay? 270 clockwise is like this, okay? And if you look carefully, these are 90-degree angles. So if this right here, let me get a different color. If this side right here rotates to right here, that's 90 degrees. And then if it rotates another 90 to right there, that's 180. And then another 90 to here, that's 270 degrees. So this side needs to end up right here. So it just swung around there. Also, 270 degrees clockwise is 90 degrees counterclockwise. So I could have then taken this and just done this way, 90 degrees. So let's put our points here now. So this is 1, 2, 3 units long. So there is C. And then we have 1, 2, 3, 4, 5 units long. So 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. And that's that. And that would be B right there. And then connect these two to A. And then it says reflect across the y-axis. Remember, this is our y-axis. So now I just got to flip this around and put our new points. So if it takes 1, 2 to get to the y-axis, it should take 2 to get to the new point. And it's the same length here. And then this one would be the same length, which is 5. And there you go. And that is A prime, B prime, C prime. Because that is our image. This is this one is our pre-image, and the blue, purple, whatever is our image. If you remember, we did this activity with the straw and like the triangle attached to it, or the rectangle attached to it, and we rotated the straw to see which figure it would become. And it's asking us on drag the ones from the right to the left, which ones would work. So if you remember this donut one, not very many people got this correct. So it's going to be that circle, because there's this little bit of space right there that makes this space. So the donut, the circle off of the axis of rotation makes the donut. The triangle makes the cone. Here's your triangle. The rectangle makes this. So there's a rectangle and it makes your cylinder, and then your semicircle makes your sphere, because there's your semicircle.